The activity is ZX94, and in the class I did the same problem except that the path that this wheel is supposed to roll on it happened to be a straight line. But on purpose, I'm going to make it a curved path here, but the steps are identical. Okay, dimensions don't matter. We just want to discuss how the process is done. Okay, so let's go ahead and start with the product file. Immediately save it. Okay, in this folder, let me make the base first, or the ground. So I'm going to switch to assembly design and insert a new part in there, and I'm going to call this thing ground. Let's make it. Double click on this horizontal plane. I will sketch a rectangle, exit, pad it, say fine. Now on it, I'm going to draw a path. For example, I can use a spline if I want to. Exit. And there is my path. Okay. Uh, that's pretty much it as far as uh, this. So we created that sketch. I would like to translate this thing upward. Translate this thing upward by uh, a certain distance. For example, maybe 5 millimeter or something like that. So let me do that. Uh, what Because I want to translate this, I have to go to generative shape design. So we will switch to uh, shape design. This is where we have a translate for surfaces and wireframes and things like that. So look under transformation, just translate. No, that's symmetry. So translate is somewhere else. Let's find out where it is. Uh, Maybe that is the one. Translate right there. Translate this curve in the direction Z. And let me make this thing 10 millimeters so it looks like 10. Preview. Okay, that's good. 10. Remember, this is 10 millimeters. Very good. You'll see why we need it later on. All right. So let's go all the way to the top, save everything, and then insert a new part. That's going to be my wheel. Say no. I'm going to call this thing the wheel. Right click properties, wheel, and wheel. And we're going to make it. So double click on the wheel on a convenient plane. So for example, on this vertical plane, I will sketch a circle like that. I'm going to make this radius 10 millimeters. Remember, I translated that guy by 10 millimeters. So this is going to be, going to make radius of 10 millimeters. Okay. And just so that I can see the rolling motion, I'm going to make a little indentation here so that later on when I make this thing move, I can see it actually roll. Exit, and where are we here? Padded. Now pad, of course, is not here, so you have to go to part design, and then we pad it. I'll make this thing maybe 5 millimeter. This is how my wheel is going to look like. Okay, and I'm going to create a point right at the center of this. You'll see why later on. So while I'm in this wheel, I'm going to make a point. The method that I use is called the circle of the center of the circle right there. All right, couple of things. First of all, I want to bring this thing down and put it over there. Okay, so we have to go to the assembly, save everything. All right, and then I'm going to say, okay, let's fix the ground. I'm going to fix the ground. The ground is fixed. Okay, and then I'm going to say contact between this face and that face. And if internal doesn't work, we make it external. I'm sure we will have to make it external. Update. You can see that it does. If it was internal, it'll go through it. Now I want to put this point coincident with this. Okay, so we're going to make a coincidence between this point and that point. Okay, very good. Now that point stays on this curve, no doubt about it. But this circle must roll on that, but it has to be tangent to it. The question is, how do I make it tangent? There are many ways of doing it. Here's the way I'm going to make it. So first of all, I save everything. I'm going to go to uh, the base. I'm going to go to the base or the ground. A couple of things I'm going to do. Number one, I'm going to make a line in this direction vertically up. Okay, so I'm going to make a line, point and direction. The point starts here. You'll see why I need that in a minute. And direction upward, but it doesn't really matter how much. Okay, so whatever that thing is, so that's really irrelevant. But just so that you can see better, I'll make it 30. So I created a line that is basically perpendicular to the surface. Then I'm going to make a plane. This is all happening in the ground. I'm going to make a plane perpendicular to that curve. So here is a reference elements. We are in part design, so there is reference elements right there. And the method is normal to a curve, and the curve is this, and the point is that. No problem. So this curve, this plane is normal to that. Now, I want, if I took a plane that's 90 degrees to that, automatically it becomes tangent to that curve. So let's create it. Another plane, create another plane, but the method that you want to use it is called angle and normal to a plane. Click on it and read it carefully. Rotation axis. Rotation axis is this line. Reference plane is this line. So I want to take this and rotate it, and I want to go by 90 degrees. There. You see, now I have a plane that is at 90 degrees. This plane, you can see that right there, right there, and it's tangent to that. So now I can say, okay, why don't we go to the assembly design, and we make this plane coincident with that tangent plane that we made. So we're going to say coincidence between this plane and that plane. And we say, okay, let's see if it works. Yep. Now you can see it's tangent to that. Excellent. All the way to the top, save everything, and we're ready to roll. Okay, go to the digital mockup, get the magic wand out, new mechanism, auto create. Okay, see what kind of joint you've got. Well, we have a revolute and we don't want it. I'm going to delete this. I'm going to delete this joint. Don't delete the children, just delete the joint. I got that joint because of the constraints that I had, but I have to make my constraints myself. So this wheel is supposed to roll on them. Okay, so here is a roll curve joint. Curve one is here. Curve 2 is this outside circle. You're supposed to roll on that. Good. And this point, which belongs, by the way, to that wheel, must stay on this curve. So point curve joint. The curve is this translated curve, and the point is the one that I just created here as in the wheel. So I can take it from there. And I say, okay, degree of freedom 1. And I can make this point curve joint length driven. Notice that here the total length of that is 202. Mechanism can be simulated. Can I do it? Let's find out. So let's do that manually, no physics here. Can we make basically a cartoon? Yep, you can see that. You see? Very good. Okay. And yeah, that takes care of this uh, activity. And notice that the steps are identical to what I did in the class when I drew a line. Identical. All right, folks. Good luck.